Well, propulsion is the backbone of aviation and space travel. And so the developments that we are making here will definitely make a significant contribution into this particular field.
Space exploration will be more challenging in the future because now we want to go to the moon and the Mars as it before in 70s. After 1972, no human traveled beyond the space station. But now the space community want to explore moon and the Mars. So basically we need to come up with very cost-effective solutions to achieve the space. So that's why the rocket project we are working on will address these solutions.
Any space mission, we work on complex projects and advancing the technologies in that system. At the end, anything we do for space missions comes to our daily life technology.
Propulsion is the heart of any space mission or any on the aviation. So the reason we haven't conquered Mars or we haven't conquered outer space is the limitations that we have in the rocket technology. Humankind ever wants to become interplanetary species, we need to keep developing this field. Developing rocket technologies will enable us to conquer the space, and on aviation is the same. If you have better engines, if you have better propulsion systems, we can bring things together.
Specifically for hybrid rocket propulsion, the combination of technology will create cost-effective launch systems. For example, right now, the cheapest rocket to go to the space is the SpaceX Falcon 9 rocket. Imagine that if we do same rocket using hybrid rocket technology that we are developing, it will be 1/10 of the price. It will be definitely a huge impact in the long term. In the short term, we do have applications in the space. For example, if you go to the moon, if you use the plastic fuel, if you use the nitrous oxide, it is storable that you can store in the space, which is in engineering perspective, hybrid technology gives you too many engineering solutions and cost-effective applications.
Advancing one is the development of rocket technologies in the country. Because with this, we can start building the whole ecosystem from not even building satellites. So there's a lot of countries that can build satellites. You can have the space technology. You can develop a lot of things. But if you cannot put the satellites in orbit, you don't have the full cycle of the industry.
Well, I'm currently working on AI-enabled control systems which help the engine of the aircraft to perform with much more efficiency and become much more smarter and become autonomous.
Sustainability, it all depends on have really efficient propulsion system. Efficient travel is also depends on the propulsion system. If you are developing new propulsion technologies, you are having sustainability travel and efficient travel. If you ever want to conquer space, we also need to develop propulsion technology.
Well, propulsion research is helping in solving global challenges by reducing the emission, by improving fuel efficiency and the space travel.
If we look onto the little bit history of space tourism or space exploration in the commercial side, we see that Virgin Galactic company, Richard Branson, and he come up with a space vehicle for tourism. That combination of the rocket was the hybrid rocket. Jeff Bezos, the owner of the Amazon, has the rocket company Blue Origin. So they are doing space tourism also. They are using liquid engines, methane and oxygen. So basically, using all the combinations of effective propellants, you can support the space tourism that we are focusing on.
So we need an optimized spacecraft that has intelligence processing units that can make decisions in a fast way, especially with the unpredictable environment.
I am Ozan Kara. I am working in Propulsion and Space Research Center as a senior researcher.
My name is Dr. Yusra AlKendi. I'm a space researcher at the Propulsion and Space Research Center.
Hello, my name is Joao Martos. Today I am the lead researcher on the hybrid rocket project.
My name is Francisco Bilendo. I'm a researcher in Propulsion and Space Research Center.
Actually, the space itself, it inspired all of us. So my journey started that inspiration of space exploration, plus specifically for the rockets, I tried to come up with the new technologies, engineering solutions, and these desires sparkle my research into the rocket systems.
During my undergraduate studies, I worked on hands-on projects which realized me that I want to pursue my career in engineering or aerospace engineering.
I've always been fascinated by flight and systems that make them possible. And so during my PhD in control theory and control engineering, I saw how powerful control and diagnostics could be, especially when applied in propulsion systems. And so this realization led me into pursuing a career in a field where I can actually make a real impact.
When I was about to finish my high school, they opened the first aerospace bachelor course in Brazil. So when I saw, I just jumped in. The reason I wanted to do for aerospace, especially when I was a teenager, was like, what is the coolest thing that you can do? So it's definitely making something to fly or sending something to space. When I started doing coursework on propulsion aerodynamics, I was like, this is my thing, because this is what keeps everything moving. So you can have an airplane, but without the propulsion system, it's just a piece of metal.
I think completing my PhD in aerospace engineering gave me the chance to enhance my skills in AI processing and algorithms and working on advanced technology. That's why I pursue my career as a space researcher.
Well, for me as a young researcher, a major milestone was my PhD research in control theory and control engineering, where I was able to apply these methods into aircraft engines and actually see the real impact of my work.
Normally, you cannot use carbon dioxide as a fuel or oxidizer. But in my PhD, I use CO2 as an oxidizer in the rocket. Basically, I burn the CO2, which is very tricky because CO2 can only burn with metal powders. Mars atmosphere is 96% of the CO2. If you capture the CO2, inject into the rocket and use as a return vehicle from the Mars to the Earth, could be a potential research field. As a milestone, this research that I did previously in the PhD had some awards, and in the following I get the World Young Space Leader Award by the International Astronautical Federation. That was the very key milestone in my career.
I was doing my master and a PhD. I had the opportunity to work on one of the most advanced technology programs in Brazil. So they were trying to develop hypersonic propulsion. And then when I went for my first work experience, I had the opportunity to work in the European space engines in a project where we gathered together many countries, so Brazil, Australia, Russia, many countries in Europe, with the same goal, which was to bring back supersonic or even hypersonic travel.
Well, I'm currently working on AI-enabled engine control systems, where we are developing systems that can help aircraft or aircraft engines to perform much more efficient, safer, and become more autonomous.
Today, I'm leading the project on the development of sounding rockets with a hybrid rocket engine. The way that we are changing the future is we are building the foundations of rocket technology in the country.
Specifically, I work for development of hybrid rocket technology. We are using very cost-effective fuels plus cost-effective oxidizers such as NOx, nitrous oxide, as in used in the cars. That we use this combination, try to come up with a very cost-effective engineering solutions to the market.
In our projects, we are developing an AI processing unit which brings the intelligence into the spacecraft that has the cost-efficient and makes the spacecraft more intelligent that can work in unpredictable environments.
As a propulsion and space research center, we are engaged with the advanced materials. We did meetings with the renewable energies and several more research centers that specifically for hybrid rocket projects. Right now, we are working to launch a sounding rocket, and this rocket has the structures with the carbon composite or glass epoxy, which is some materials that ATRC is supporting us. Fins of the rocket, ATRC is supporting us on the manufacturing. So basically, from top to bottom, rocket project needs the collaboration, and in TAI, we are doing that very positive way.
The way to move faster and further is by cooperation. It's harder to get cooperation, but whenever it's possible, we try to cooperate with teams that have experienced that problem before. The main point about a cooperation, if someone has made the same mistakes or the same contributions before, they can help you to move faster on the same direction.
In specifically for hybrid rocket project, we collaborate several entities in Europe, US, and South Africa. So we try to find exact institutions who can support us in the sounding rocket project and the rocket development, and we have a very active collaboration with them.
We are collaborating with international university, and that university has more than 3 decades of space experience. So we are benefiting a lot from that collaboration, and it will enrich our knowledge in the space, especially we don't have much experience for space missions.
Well, the transition and the move towards intelligent and self-adaptive systems, along with sustainable fuel, electric propulsion, I think these are the things that will define how we fly and how we explore space.
The cost-effective solutions using chemical propulsion system are coming up. If you follow, the SpaceX has the Starship rocket, specifically designed for the Mars. So in 20 years, I believe, especially SpaceX will reach to the Mars by using these huge rockets, Starship. Specifically for low-cost commercial space sector, there will be new technologies that we will achieve the space 1/10 of the price as we compare the now. There are the nuclear propulsion systems are developing a lot that will be used in the space to go different destinations and reduce the timing, space travel timing.
Having UAE being capable of launching satellites and going to space, so enabling UAE to reach space. So everything that we do today in TII is with the end goal that these technologies can be used later in a bigger program that will take the nation to space. So if in 10, 15 years we have UAE being able to launch its own satellites, I think we'll reach the highest goal that we can ever imagine.
Well, our work lays the foundation for smart systems by including AI, control, diagnostics, and prognostics. I believe we are working on the next generation systems. Well, as a team member of a highly collaborative team, my day starts with a 15-minute stand-up, which is a meeting where everyone within the team has the opportunity to give updates on what they are working on, address certain challenges, get certain feedback from the lead researcher. And then I go on about my day in analyzing results of the previous day and make some improvements according to the roadmap of our project.
So we are always working with projects that they are relatively dangerous, but we need to make sure that we are doing everything in a safe way. So I would say most of my day I spend on the design, reviewing procedures.
I wake up very early, 5:30 to 6, do my workout, and then get prepared for my day. After I come to the office, we try to meet with colleagues about specific points, for example, propulsion, electronics, avionics, or any other software applications. And then after work, I try to go and work my rehearsals about singing or meet with my friends.
I start my day with greeting my friend with good morning. Then I start revising the simulation result or experimental result that I had. The rest of the day is splitting into coding, writing reports, and analyzing the performance of the current models that I have.
I recently worked on integrating a sense of fault detection in a microcontroller. One of the main challenges that I faced is establishing a real-time and accurate communication between different parts of the system, which was solved by accurately and carefully scaling the signals and hardware tuning.
All rocket applications need testing. Key point in our project is testing and development. So we are doing that. And of course, the testing and development needs some safety procedure. Inside the test field, you need to wear your safety equipment such as helmets, glasses, earplugs. I am the test director, try to make the safety of all the personnel.
So the most challenging thing in the spacecraft projects is how you optimize the data processing. Relying on conventional processing algorithms, it always consumes a lot of power and also memory. Therefore, we are seeking novel solutions driven by AI and advanced processing units that will help us to overcome this challenge.
This is relatively easy because I really love what I do. So even when I'm at home, I'm usually reading about aerospace in general. So it's hard to split between what is work and what is not work. The interesting part is also we always need to put a time off. So I try to, as much as possible, spend most of my time with my family, trying to relax and remove a little bit.
Well, the major part of the day I spend in our research center where I work on my daily tasks. Within our company, we have a community where we can explore different sports, and we are able to meet once a week and actually enjoy this particular sport.
As a rocket scientist, people ask, how can you be a rocket scientist while you are a photographer or singer? So I usually try to manage my time. Wake up early, do my progress 2-3 hours before work and after work also.
I think creating things is one of my hobbies. So developing algorithms and seeing how inputs reflected and become an output, it is like relating the things I love to do with the work.
Well, skills such as control, diagnostics, prognostics, thermodynamics, fluid dynamics, and also the integration of artificial intelligence in recent days. I believe with these particular skills, you can go a long way.
Being curious and hands-on, and they must know how AI do. A lot of technologies around us is related to AI. So they need to do programming, AI. They have to know the foundation of sciences and engineering.
Curiosity and testing for rocket systems. They should always try to test the systems rather than only theoretical calculations, because you will understand real materials, compatibilities, safety if you really test a system or a device.
Social media. Today, social media is a powerful tool, especially if you are following the research institute, the companies in social media like LinkedIn, X, you can see what they are publishing and what they are doing. The second topic is if you want to go deeper into what they are doing, I think is always looking for papers, looking what they are publishing, what analysis they are doing, and also going to conference. So going to conference, meeting the experts and seeing what they are presenting about what they are doing is one of the key things to do to stay updated.
Well, I follow up with top journals, and I try to attend as much conferences as possible and continue to engage within the global community of researchers.
Always stay curious and hands-on, do a lot of experimental work and engage with others. Keep yourself open to interdisciplinary learning. Relate your work to global projects or global challenges.
try to engage with the advisors, try to engage with your colleagues, and improve your mindset about the propulsion systems, and follow international institutions such as SGAC, Space Generation Advisory Council, or International Astronautical Federation, because these entities are very critical.
Well, I would advise to engage in solving real-world problems. Stay curious and persistent, and you can go a long way.
I think the main advice I would give is always don't give up. I will not say that it's easy to become an aerospace or a propulsion engineer, because you are always dealing with the most advanced technologies that you can think about it. We are always in the edge of the knowledge, and never forget about the base. So if you have this building in your core, the physics, the mathematics, programming, you can go anywhere, because deep down what you are trying to do is trying to understand, try to describe a phenomena, try to describe it mathematically, so we can find solutions for that. So never forget about teamwork, working with your colleagues, communication skills, because the only way to move forward is in group, and to move that you also need to play your soft skills with a solid foundation.